in the afternoon after lunch. Like we can have a longer session.
Okay,
so
okay.
we can do more stuff.
Yeah.
Right?
Okay.
Okay, we can do like the whole 10 years. How about that?
Really?
Okay,
okay.
Why? You want to get A or not?
Yeah, I want to get A.
Yeah, say one reason why the liquid changes to vapor. Obviously, it's not boiling. So why the liquid changes to vapor? Well, how to answer this question? Why it changes to vapor? Because there's no heating source to increase temperature to 100 degrees Celsius, right? You need 100 degrees Celsius for boiling to take place. Do you understand this thing?
Hello?
Huh?
Yeah, I didn't catch
What?
what you said.
Oh, okay. So the question is this: they put this thing here, so they are saying why was it evaporation rather than boiling? Like this thing will dry, right? Because the water evaporate, right?
Yeah.
How come this process is not called boiling? Why is it called evaporation? Because there's no fire.
Yeah.
There's no fire burning all this, right? So it doesn't make sense to call it boiling, just evaporation.
Okay.
And the evaporation takes place at all temperature. Evaporation takes place at all temperature. This is not boiling. Boiling only happens at 100 degrees Celsius. Okay? So for part B, state and explain from which sheet evaporation occurs at a greater rate. So which one will there be more evaporation? Obviously this one, right?
Yeah.
And why? Because it has a bigger surface area. These 2 marks. State how the rate of evaporation changes when the temperature decreases. So when the temperature decrease, rate of evaporation also decrease. Why? Now, why is it that the rate of evaporation decrease? Because the particles, you see, when the temperature decreases, right, particles move slower, right?
Yeah.
Alright, so when they move slower, they will not be picked up by the wind. For evaporation to occur, they have to be picked up by the wind. Right, so when the temperature is lower, the particles move slower, so there's like less windy, not only that, so there's less energy, hence fewer molecules possess enough kinetic energy to overcome the attractive forces to escape from the water surface. Alright, so I think this is pretty easy. The first question is like a giveaway, 5 marks. Right. First 5 marks is easy. Next one. Yeah. 2. So a brick has length 0.21, width and depth. The density is 230. Found the volume. So what's the formula for volume? Density.
Density equals mass over volume.
Mass over volume. So we are given the density. You want to find the volume. First find the volume. Length times breadth times height. Right, so it's 0.21 times 0.1 times 0.06, and we get 0.00126. Alright, so round off is 0.0013 meter cube. So determine the total weight of 30 bricks. So we want to find the mass of 1 first. Let's find 1. Now using the formula, density equal mass over volume. So I have the volume. So my density is equal to, okay, to find the mass, M is equals to dV, right?
Yeah.
So what's D? D is 2300. Density is 2300. So gotta multiply with 0.0013. Okay, we get 2.898 kilogram. So this is 1. So there's 30 of them. So we take 30 times 2.898. 30 times 2.898, we get 86.94. Right, so this is the mass, but they want the weight. So the formula is W equals what?
mg.
Mg. So you're gonna take the mass, 86.94 times 10. So the weight becomes 869.4 Newton. Okay?
Yeah.
That's the calculation. Next. Okay, so the 30 bricks are carried in a wheelbarrow as shown. So the weight of the empty wheelbarrow is 110. The line of action, blah, blah, blah. Calculate the force needed at the handle to hold the wheelbarrow and bricks in position as shown. Okay, so this is a moment question, right? Moment. Now, what is the weight of the wheelbarrow? It's about 870. This one round off, 870 Newton. So 870 Newton is downwards. So far, okay? Now, where is the pivot? The pivot is here. So what is the formula for moment? So I want to calculate the clockwise moment. Clockwise moment is here.
Yeah.
Yeah, so it's 870 times 0.8. Wait a minute. No, still haven't finished yet because the bricks is 870. There's also the wheelbarrow. Wheelbarrow is 110. Alright, so this one is you got a plus 110. No. You understand? The total clockwise moment. So clockwise moment equals to force times distance. So it's 110 plus 870. That's the total force times 0.8 meters. Clockwise moment equals to use calculator. 110 plus 870. 0.8. Okay, 784. Okay, so the clockwise moment is 784. Now we have this guy who needs to lift up here. Alright,
Yeah.
now what's the total distance? Total distance is 0.8 plus 0.5, which is 1.3 meters. Now he needs to overcome a moment of 784. Alright, now this upward direction, is it clockwise or anti-clockwise? Upward is anti-clockwise, right?
Yeah.
Yeah, ACW, anti-clockwise moment is equal to 784, right? So this Newton meter and M. And it's also equals to 1.3 times F. So 784 has to be 1.3 times F. So how do you find F? 784 divided by 1.3. I get 603 Newton. Okay, so the force here has to be 603 Newton. Is it okay so far?
Yeah.
Can? So this is based on the principle of moment where the clockwise moment goes to the anti-clockwise moment. Alright, so next question. Okay, this one?
Yeah.
Okay, next, when the wheelbarrow is used on muddy ground, it pushes along. Why the wide plank reduce the risk of wheelbarrow sinking? Why did they use a wide plank? So a wide plank has increase the surface area, right?
Yeah.
Right, increase surface area as compared to the wheel. So when the surface area is increased, what happens to the pressure? Remember, formula for pressure equals to force over area. So when area increase, pressure will decrease.
Decrease.
So when the pressure decreases, it will not sink into the mud.
Yeah.
Right? Simple. Next. Oh, were there any organic chem question today?
Trying to remember the question.
Can't remember, doing don't have. Okay, next. Okay, so a car of mass 1.1 accelerates uniformly from rest to 37 meters per second 6. Calculate the resultant force. So formula F equals what? F equal M
Equals
A. So I need to find the A. I have the M, right? But I don't have A. How to find A? V minus U over T, right? A equal B minus U over T. So it's 27 minus initial speed 0 divided by 6. So my A is 4.5 meter per second squared. Now to find F, if 1.1 times 10 to the power 3 times 4.5, I will get a value of 4950 Newton. Okay, 4,950 Newton. So far, okay?
yeah.
Awesome. The distance traveled by the car. Now, to find the distance traveled by the car, you gotta imagine a speed time. Speed time. Now, how does the car travel from 0 to 27 in 6 seconds? 0, this is 6 seconds, right? So from 0 to, what was that?
My
Sound.
nose.
What?
My nose.
Your nose? Oh my god, sound like some weird thing, like some alien, you know? Alien sound. Okay, so anyway, speed time graph. I don't find distance. Where is the distance?
The gradient.
No.
The area.
Area. Okay, how to find area? Half times
Base times height.
base times height. Alright, so key into calculator, we get a value of 81 meters. Right? Easy enough.
Yes.
Yes, work done. What's formula for work done? Force
times distance.
time distance. So it's 4950 times 81. Alright, we'll get 400,950 joules. Everything use what? Formula. You score another 7 marks here. Alright, next. Okay, so a rock of 20 Newton is thrown through the air at a particular time. A force of 50 Newton acts on the rock at an angle of 45, as shown. Now, incomplete vector diagram is shown. Wow. Okay, complete the vector diagram. So, how to complete this vector diagram? Now, first of all, you see you have a force. Okay, what we do is very simple. We just try to draw a parallelogram. You understand what's a parallelogram?
Yeah.
Like this is 1, 2, 3, 4. 4 boxes down. So 1, 2, 3, 4. A bit bigger. 1, 2, 3, 4 here, and just take 1, 2, 3, 4. And connect to here. Okay.
Yeah.
Now, where is the force? Where's the resultant force? You see, you have one going upwards, you have one going downwards. Where is the thing going to end up at? Diagonal.
It's always diagonal, is it?
Yeah, the green color line. Okay, so all you have to do is to measure. You take a ruler, measure the length of the green color line, and you see the scale 1 cm equal 5. You determine using vector diagram. This is called vector diagram. You should get 38. Okay, vector diagram. Easy enough.
So is the force always the diagonal?
Yeah. No, you gotta imagine. You imagine this. Someone pulling 50 Newton up. Another feather pulling 20 Newton down. Where is the thing going to end up at? Here, ma. You know what I'm talking about?
Yeah, I do.
Yeah, so that's it's the diagonal. It's always the diagonal. I mean, you have to look at where the arrow is, right?
Yeah.
Where is the arrow? It's not,
Yeah.
right? But so this is pretty okay. So just 3 marks. And we go on. Okay, favorite question. A wave in the visible region has a frequency. So this is F, right?
Yeah.
This is F. Frequency. Wavelength. What's the symbol for wavelength?
Lambda.
Lambda. Micrometer. Nano. Wait. Milli. What's that? Micro, right?
Milli.
Milli. Micro lah. Micro.
I thought
Micro. 10
micro
power
is,
minus 6. Okay, so what's the formula between V and lambda? V equal what?
F lambda.
F lambda. So to find the V, you take F, which is 5 times 10 to the power 14 times lambda, which is 0.6 times 10 to the power negative 6. Okay, so that is micro. Micro is 10 negative 6. So just key in calculator, you get 3 times 10 to the power 8. And sure. Right, so formula is important. Okay, please memorize all of them. Okay, next, electromagnetic spectrum given X-ray, radio waves. Use the words in the list to complete the thing. So, Grandma X use Viagra in my room. Okay, so X-ray is here, radio wave is here. Right. So, wavelength, speed in the vacuum, which one is higher, which one is lower, which one is equal? Now, the speed is equal, correct?
Yeah.
Because all of them belong to the electronic magnetic spectrum. They will be traveling at the speed of light, which is 3 times 10 to the power 8.
Yeah.
Now, next, in terms of wavelength, which one is bigger? Which one is longer? Which one is shorter? Radio wave, here
The
is longer.
radio wave is the longest, yeah. Then the gamma
Here is
is
shorter.
yeah.
So wavelength here is longer. This one is
Shorter.
shorter. X-ray. Okay, how do you remember? X-ray, gamma ray.
I just remember the last one is the shorter, longest. Then for now shorter.
Yeah, radio very long, right?
Yeah.
Something like that. Okay, so about the frequency, which one high, which one low? Now, because this guy have a short wavelength, right? So it's high frequency.
Yeah.
This one long wavelength, right? So it's low frequency.
Yeah.
Okay, so R is lower, so it's higher. Okay, so you got a grandma save the day. Thank the grandma, grandma X, whoever you are, right? You save our lives. Next, draw a line to indicate a wavelength of the wave and label this W. So where is one wavelength? Is from here to here.
Yeah.
Correct?
Yeah.
So we call this is the color. So there's W over here. W, right? It's from here to here. This one, here to here. Okay, one wavelength. Next, we are supposed to draw mark. Where is rarefaction? Oh, where is rarefaction? Air pressure, very high. Oh, so you see this is high air pressure. So this must be compression. So rarefaction here. Right?
Wait. Why? What? So
What?
if it's higher air pressure.
That this compression, this one is rarefaction.
Then if it's low air pressure,
Rarefaction, no?
it's the opposite.
It's not compressed, The gas particles are not compressed, you see here? Not compressed, So less air pressure.
Okay.
Next. So state what happens to the sound as heard as the distance increase. Can you see as the distance increase, what happened to the loudness? Loudness decrease, right?
Wait,
Hello?
what?
What happens to the sound as the distance increase?
Oh yeah.
The loudness, the sound becomes softer. Sound becomes softer. Now you gotta use common sense, to answer this question.
Yeah.
Now even if you don't know what the graph is talking about, what happens when you increase distance? Softer, right?
Yeah.
Don't be tricked, right? Next. Okay, so two small and oh my god, this is your favorite question. Okay. Let's try and see what happens here, right? Rod X and Y are both conductors, how using insulators, rods are moved and spheres move apart. What can be deduced about rod Y? Okay, so first they move apart means what? Repel, right?
Yeah.
Repel.
Like
repel means what? If this one plus, here also? Plus or minus? Rod Y, is it plus or minus?
Plus.
Yeah, because it repel. So we say rod Y is positively charged. Right? So they repel.
Yeah.
How do you know? Because they repel. Say actually what could be deduced about rod Y? Okay, so how did it become positively charged? Here, you gotta say that when they touch, right? When they touch here, the positive charge went in. Okay? The positive charge goes into rod Y, then when
neutrally charged, is it?
What?
It's a neutral.
Neutral. No. The positively when it touch the sphere, the electrons flow from A to rod X. Electrons flow from A to rod X, causing A to be positively charged.
A to rod X?
Yeah, electron. Electron go, when they touch, the electron go here. Alright? So A become positive charge. Now after A become positive charge, sphere B is also positive charge. This one also become plus. And as the metal sphere move apart, rod Y is also positively charged.
But wasn't A already positively charged?
No, not yet. Only when the rod, you see, rod X is positively charged and touches the sphere. So imagine at first this rod X is far away, right? So they bring it near and touch the sphere. So when they touch the sphere, electron move in, then this ball become plus. Then when this ball become plus and they touch the B, this one also become plus, right? Then the rod Y touch, this one also become plus.
So rod X was previously positively charged,
Yeah, it's the first. Okay, this guy is the vampire, right? This one bite this one.
Okay.
This one become vampire. This vampire bite this one. This one also vampire. Vampire bite this one. All become vampire. Okay?
Okay.
That's the best explanation I can have. So every guy is positive and they repel.
Yeah, okay.
Alright, but it's because of the flow of electrons, okay?
Yeah.
Yeah, alright. Well, you see, vampire theory 2 marks for you. Thanks. Okay, this is my favorite. Electricity. Okay, the combined resistance of all the resistors in the circuit. You see, we have trained how many years for this? 3 years, right?
Yeah.
3 years. Okay, so between the first guy and second guy, is it series or parallel?
Series.
Series. So you plus them, right? So 8 plus 2 equals to 10. Then between this one and 10, it's parallel. So
Yeah.
1 over 10 plus 1 over 6. Okay, 1 over 10 plus 1 over 6. So this is 1 over RT.
Yeah.
Right? So I want to find RT. So you get the answer, you remember to flip. So RT is actually equals to 3.75 ohm. Okay, so we get 3.75. Right? That's how we get this. Next. What is the current in the resistor of resistance 8 ohm? What's the current here? Current.
Current Q equals IT.
V equals what?
V equals APT IV. V equals IR, yeah.
Yeah, so I don't find I. I equals to V over
R.
R. Now what's the voltage here? In the middle, what's the voltage? 12 volt. Here also 12 volt. How come? Because parallel, right? Parallel V1
yeah.
V2 equal V3, right?
Yeah.
So all the V's are the same. Now the total resistance here is 10. So if the total resistance is 10, I equal V over R. I take 12 divided by 10, so it's 1.2 ampere. So here is 1.28. Okay?
Yeah.
So for part B answer is 1.2 ampere. Next, the power dissipated in the resistor of resistance 6. So I want to find power. How to find power here? Use our triple triangle E, P, T, I, V, I, R. Right? What's the formula for power?
Power equals
P equal IV.
Yeah.
Right? So P equal IV. Now I have 12V, but do I have I? No. No, I don't have I. How to find I?
I equals POV.
No lah, here don't have Q. Where you got Q?
V equals
How to find I?
V equals
I equal V over R. Look at this formula. I equal what?
V over
I equals V over R. I equal V over R. So our V is 12. Right? The R is 6, right? So what's the I? I is 2. So these two are the same. It's 2 times 12 equals to 24 watts. Okay, so P is 24 watts. So we are blessed with another answer.
Yeah.
Next. So the charge flowing through the battery in 10 minutes. So this is I equal Q over T. So this means Q equal to I T, right? So battery.
10 minutes.
Now I need to find the total current.
Yeah.
What's the total current?
V equals IR lah.
Yeah.
You take the total volts plus the total resistance.
Yeah. So total volt is 12, right?
Yeah.
12 divided by
3.75.
3.75. What do I get? 12 divided by 3.75. I get 3.2. 3.2 ampere.
Yeah.
Okay, so I need to find IT, right? So 3.28 times 10 times 60.
Yeah.
Times 10 times 60. So it's 1920 coulomb. Okay, so our formula EPTIBIR give you about 10 marks, 4 marks, 8 marks, 8 marks. Yeah. All right, formula set of the day. Next. Oh man. You know.
What was that?
I don't know. Skip.
3 marks. Oh, okay.
Draw an arrow on side BC to show the direction of the convection. Okay, we don't give up, right? We try. We
Okay.
try. So what's the direction of conventional current? BC. BC. Conventional current is from positive lah. So go out here. So like that, no? Right? Current flow this way. Come out from plus.
Okay.
Draw arrow to show the direction of the force. Now you got to use the right hand rule, right?
Oh.
Use the hand rule, right? So here is downwards, and this one is upwards. So because of this, it will turn. Okay, that's 3 marks.
How do you?
You gotta go and figure out the left hand, right hand. I can't draw a hand here. Alright, I can't show you here, but you go and figure out. Next, this one can? 3 marks.
Yeah.
Never mind. Okay, so answer any 2 questions.
Yeah.
Calculate the kinetic energy. So rings a bell, right?
Yeah.
Energy half what?
Half mv square.
Yeah, half mv squared. So half times m 1.3 times 10 to the power 5 v. What's the v?
Ne?
Where?
2.3.
Oh, 2.3. Oh, okay. Some printing problem, right?
Yeah.
It's a 2.3.
Should be km per hour.
Okay, times 10 to the power of 3 meter per second squared.
Why times 10 to the power of 3?
Because it's okay. Let me look at the book. I think it says 2.3 kilometer per second. Wait, per second. Sorry, it's per second.
Per second.
Yeah, so it's 2.3 times 10 to the power of 3. But we need to square it. Some are square. Square.
Why?
Half mv square.
Oh yeah. Okay.
Right. So using the calculator, we get a value of 3.4 times 10 to the power of 11 joules. Okay. Formula. Right. Next. Explain why the speed of stage 1 decreases as stage 1 rises, speed decreases. Why the speed of stage 1 decreases? Stage 1.
Why the speed of stage 1 decrease?
Why the speed of stage 1? What? After stage 1 detach. Oh, okay.
Stage 1
Okay, stage 1 is referring to this part.
Yeah.
This part, right? So after it detached, right, it's actually still moving, it's still flying due to momentum.
Yeah.
So, but there's no more fire, no more already. So it just keeps going due to momentum, but eventually the kinetic energy will wear out because there's like air resistance.
Yeah.
Because there's no more upward driving force, and therefore it decelerates and the speed decreases.
Okay.
Alright, next. Stage 1 falls back to Earth. This is the vertical speed.
Yeah.
Describe how the acceleration stage 1 varies as it falls to Earth. Now this is a speed time graph. Now, where is the acceleration in the speed time graph?
The gradient.
Yeah, so what happens to the gradient? Decreasing, right?
Decreasing.
Until no more, right? So acceleration is decreasing. So decreasing.
Yeah.
Acceleration. Okay, so there is decreasing acceleration. It's basically dropping down until it hits a constant speed. Okay, until no acceleration, and therefore constant speed. Okay, which is a constant speed. Why? Because of air resistance. So the resultant force. Okay, so this constant speed happens when the air resistance is equal to the weight of stage 1. Right? At this point. Okay, this point is where the air resistance is equal to the air resistance is equal to weight of stage 1, and therefore no acceleration at that point, and it falls back to Earth at a constant speed.
So the reason is because there's a decrease in acceleration. There's a decrease in acceleration until...
decreasing acceleration. Now, why does it decrease acceleration? Because there's no more upward driving force. So when no upward driving force, it will start to come down, drop down. Okay, sorry, this is the falling part. So falling part, as it's falling, right, it will, at first it will accelerate at this point. It will accelerate while it's falling, but the falling down rate will decrease because when this thing is falling, there's air resistance. Right?
Yeah.
So you reach a point where the weight is equal to the air resistance. This part is the weight equals to air resistance.
Yeah.
And hence there's no resultant force. Once no resultant force, acceleration equals 0.
So once it's equal, there's no resultant force and is equal to 0. Is it? Once it's equal to...
And the weight equal to air resistance.
Yeah.
There is no acceleration.
Okay.
Right?
Yeah.
And this is the point where resultant
is equal to 0.
Force equal 0.
Okay.
That's it. Okay. What's the energy conversion as stage 1 falls at constant speed? So it's falling constant speed. So GP change to what?
Kinetic.
No, don't have kinetic. Constant speed. Change to heat.
Heat.
Constant speed means no increase in kinetic energy, right? Constant speed, constant speed. So you cannot say change to K,
Okay.
Alright.
Then what did change to heat?
What?
What's the reason?
Oh, friction. Air particle friction.
Oh, okay.
Yeah. Okay, so it's quite okay. This question quite okay. This is one question. Okay, next. Are you a fan of glass? Critical angle?
No.
No.
Depends what the other question is.
Okay, look at the other question. Are you a fan of the fridge?
Oh, this is
Thermal energy. Heat.
Okay.
Okay, so alright, so there's a insulator, right? So heat is conduction, convection,
radiation.
Yeah, radiation. So they're basically asking you how does the fridge prevent the transfer of thermal energy? Explain how thermal energy can be transferred through the insulating material, but only at a slower rate. That means heat can still pass through. Why heat can still go in? Which one is it? Is it conduction, convection, or radiation?
By
Okay. Conduction, right?
Why
Now,
con-
because you see, this is a fridge, right? So in the fridge, they have insulating material.
yeah.
It's insulating. Now, is the insulating material vacuum? Not vacuum, right? It's not vacuum, no. Insulating material means what? Styrofoam, plastic.
So then can't
Right.
you also lose heat to convection also?
Huh? How to lose heat through convection? This gain heat.
It
I'm
means
asking about
gain heat.
how it gain heat.
It can also gain heat through.
No, there's no heater. There's no heater. They're asking how the heat can still travel inside.
So it's only conduction. Is it?
Yes, conduction. So you gotta talk about you describe the conduction process, right?
Yeah.
When the particles start to move, they vibrate. Okay, so the heat particle touch the material, right? You zoom in. Now you zoom in. These are all particles, right?
Yeah.
So the particles start to touch each other.
Yeah.
Zoom in further. There's still more particles while they are inside. So the particles basically touch each other and vibrate. And even though it's insulating material, but there's still particles touching each other. But the only reason why it takes less time is because the insulating material could have air particles in between. So the particles are further apart.
Oh, further apart.
The particles are further apart. So it takes a bit of time
Okay.
before the heat can travel inside.
Okay.
Okay, so that's basically how many marks? I don't know. Right.
But I have to mention that because the insulated material is not vacuum, it's not in a vacuum.
Yeah, it's not vacuum. Insulated
Okay.
material like styrofoam is still particles.
Okay.
Yeah, so the particles are still touching each other.
It's just that they have air in between them.
Yeah, they have some air. That's why it's a bit slower.
Okay.
Okay. So on average, the freezer uses 0.58 kWh. Calculate the power consumption. Okay, power consumption 0.858 kilowatt hour. Calculate the average power consumption. So power consumption means we want to find how many watts, right? So EPT. 0.58 kWh means 580 watts.
Yeah.
Times 60 minutes, right?
Yeah.
In 1 hour. So to find P, we need to take E divided by
T.
T. So this number must times 60, yeah.
Okay.
Right. So this is actually equal to 2088000 joules. Okay, so the E is this one. So to find P, I must divide by T. So I take 2088000 divided by
60 times 60.
yeah, 60 times. Okay, this per day. So I must times 24.
Okay.
Right? Remove all the time. I'll get 24 watts.
That's
So about 4 watts.
okay.
Alright. Not easy calculation. Okay, last question. 4 marks. The freezer is connected to the mains. Okay, what does the question? State the type of fault that could cause the circuit breaker to operate. Describe how the circuit breaker switches off the current. How does circuit breaker switch off the current?
The circuit breaker will break.
Yeah.
State the type of fault that could cause a circuit breaker to operate.
Okay, let's analyze this, right? Reset button, contact, iron, terminal, springy metal.
Can I say a sudden surge in current?
Yeah. Oh, I know already. Okay, you see, so I first here is connected, right?
Yeah.
So red color is the electric current. So current can still pass through.
Yeah.
In this way, right?
Yeah.
This one is closed circuit. Open circuit, electric current come here.
Yeah.
Pass through.
Cannot
Then,
pass through.
because open, here is open circuit.
Yeah.
This one open circuit.
Yeah.
Right. So how did this become this?
Oh, that's what
look at this part. So the idea is when too much current is passing through, when there's too much current, right?
Yeah.
This thing become magnetized.
Yeah.
Okay, magnetized, the iron armature will attract, right?
Mm-hmm.
When it go this way, it will dislodge this little hook. The little hook will move up.
Huh? But why would it move up if it becomes attracted?
This is a springy metal thingy. It's trying to move up.
Oh, okay.
It can't move up because of this little thing.
Okay.
But now too much current.
So it moves forward lah. That iron armature gets attracted to the solid.
Yeah. So this thing move up. So when it move up, you get this.
Okay.
This is an open circuit.
Okay.
Open circuit means no electric current.
Yeah.
That's it.
You can
put it in words. You must put it in words, right?
What type of fault that can cause the current is just like too much current lah.
Too much current, no? Too much current, this thing become like,
magnetized.
Super power, magnetized.
Okay.
Yeah, that's it. That's 4 marks for you.
Wow.
Yeah, can pass, right?
Yeah.
That is the last question. Okay. So what's the conclusion? Memorize all formula, please.
Yeah.
Okay, all formulas. You will definitely need formulas.
Yeah.
All right. So try to memorize formula. Okay, I will end here today. I'll see you tomorrow.
Okay.
All right. Tomorrow is Thursday. Now I got a lot of free slot tomorrow. If you want, you can come earlier. You don't have to wait.
I don't have any school tomorrow also, so I can have any time.
Then we do it like maybe 4 o'clock.
Okay, sure.
3 or 4 something. I message you again.
Yeah.
That means somewhere in the afternoon after lunch, like we can have a longer session.
Okay.
We can do more stuff.
Yeah.
Right?
Okay.
Okay, you can do like the whole 10 years. How about that?
Really? Okay.
Why? You want to get A or not?
Yeah, I want to get A.
You want to pass or not?
Yeah.
Then better do 10 years, okay?
Yeah.
Okay, see you tomorrow. Maybe let's set at 1 o'clock.
So 1 o'clock? Okay.
Should be okay. I message you again, right?
Okay.
Okay, bye.
Okay, bye-bye.